Nice. Okay. I'm just waiting for it to pop up on the channel.
Yeah, that's what I'm doing too. Heck.
Mm-hmm.
Should be going. What's happening?
Mm-hmm.
Alright, we can just start. It is going, so.
Okay.
Because we got a current viewer. It's probably me.
Lucky.
What the heck? Okay. Your YouTube is not. What?
Is it not working?
I don't know. It's doing something weird. Let's just start going and see what happens here.
Okay. Oh, the Jamboard. All right.
Okay.
So I was thinking some of the topics, assuming people don't get on and ask questions,
Which you can do, by
we
the
can
way.
have.
They can ask questions, right? If they send an email to after.math.livestream@gmail.com.
Right. So some topics that we could talk about. We could do like models of population growth, and that can tie into COVID and
Oh, that's why. Hold on,
different.
Jin. It's. Why is that happening? Hold on. I'll go black for a second here. Edit. It's on private, that's why no one's seeing it.
Uh,
Okay. There we go. So you wanted to talk about population growth and population growth models?
we could do that. Then I thought like we could talk about Newton's laws and kinematic equations. We could talk about derivatives and applications, same with integrals and applications. That can lead us into some differential equations if we get there. Um, we could talk about thermodynamics, waves, optics, electricity, magnetism. Obviously, all of this isn't going to happen tonight. uh, and then we could talk about like relativity, quantum physics if we feel real lively in a day. And we could also talk about electric circuits and those are just different things that we could come up with.
Those all sound like great things. But I think
Yeah,
tonight we should start with population growth again and kind of do what we did last time, but we were having an audio issue, so hopefully tonight we won't run into that same issue.
right. Um, do we know if Kelsey is on right now?
I don't know if she's on.
Or I can ask her in the chat. Ask her if
We
she can
got
hear
two
us.
viewers, so um, can anyone hear us?
Yes.
Is anyone out there?
Is
Oh, we got four
is there
people.
anyone?
We're up to four people now. Jake, oh, we got a
Okay.
question. We got what's 2 plus 2 from Jake.
Oh, okay.
Here,
That's a tricky question.
Jane, you want to take this one?
Um, yeah, let me write it. Oh, you already wrote it down. Okay. 2 plus 2.
That's a 4. Dude,
I was jumping the gun. That equals 4 if we are in the domain of all real numbers, right? Or we can draw a fancy R for being in the domain of all real numbers. Um, but if you're talking about 2 plus 2 mod 3, then it's not 4, right? So that's why it's but generally, right, it equals 4. So
okay, we're back up again. I don't know what's happening here, but okay. So, let's talk about exponentials, shall we?
yes. Let me get um
That makes sense. Ah! Look at him. Look at that one.
all right, is it cool? We're back up. Okay. So there's different types of growth, right? You can have a linear growth, which means it's a steady growth, just constant change with the growth, right? So if you increase by 2 every day, you're going to look at a linear growth where it's just increasing steadily 2 every day. But then there's exponential growth where it starts off a little slow and then you get a steep curve and it looks something. Oh, let's just get that.
Yeah, let's get that graph going here.
uh, yeah. Okay. So if we have, try our best to stay on the lines. What I was saying before, linear looks like a line. Ignore that curve at the bottom. Uh, and an exponential growth looks more like this, right? Where you have a greater change much more quickly and it grows exponentially. That's where the word comes in, right?
Okay. Yeah. So, Jaden, I guess how does this relate to things like I've heard a lot in the news. We're talking about COVID and exponential growth of COVID cases. So how does this all fit into that?
So with COVID, this has the potential to be like an exponential growth situation where we have a couple people at the beginning, they give it people, and then those people have the same chances to spread it to even more and more people. So it looks like a curve like we have on the right, right? It's not exactly like that, but if we model, we'll just say a dot is a person, right? And let's say that person infects two people. And then those two people infect two people. And so on and so forth, right? We get this doubling effect.
All I'm saying, dude, is I like my
So
pictures better than yours.
your picture was
Yeah, you gotta draw little people,
definitely.
dude.
Yeah, yours is a lot better. We'll let Kip be the artist for our purposes. uh,
But
but this is an exponential growth type situation where you see it just grows by doubling every single tier. You get doubled and doubled and doubled, and that grows fast. Let's write down just a couple, right? So if we start with 2 and we double it, so that'd be 2 squared, that equals 4. Then let's skip to cubed and go straight to 2 to the 4th. That looks like 16. And then 2 to the 6th, that is 64. And so on and so forth, right? We get this very rapid growth that happens just a lot quicker than you would imagine.
okay, so if I'm
Um,
so
do you
getting
have
this,
anything
it's
to
well,
add?
what so to model if it was changing, so we've got right now this is the spread is doubling every time, right? And we model that by
Yeah,
putting the 2 down here and then putting an exponent to it. So if we were to say instead of doubling every time it tripled, then it would be 3 to some number, right? And
right,
so on and so forth. So it's so the bottom number is how much it essentially, it I guess grows by each stage, right?
right. That's a good point to bring up. Um,
But I've got one more question here, Jaden. We've got it starting with just 1. So how do we, if we've got like a 2 here, how do we make this equal 1?
uh, 2 to the 0 equals 1.
Okay. And is that
Okay,
only
so that's
true?
like they say that again.
Is that only true for 2?
That is true for every single integer besides 0. 0 to the 0 is a mess. Working with 0 is just a mess, right? Like a number divided by 0, you get into a mess. Okay,
Yeah.
so it works for every integer besides 0.
Okay. Hey, we just got in the chat, we got a comment from Kelsey saying, so exponential growth is a pyramid scheme. And I was like, yes, exactly. You're right on. That's exactly what
Yeah,
it
it
is. And so
looks like that.
yeah, so we could take a tangent real quick off of COVID and talk about another
Yeah,
um, kind of pyramid scheme-esque thing that I was once, told to get involved with. And my understanding of exponentials really helped me out
right.
to be like, well, wait, this is a bad thing that you're trying to get me involved in. So
You're
I'm
like,
gonna I'm
no,
gonna go to a new page. And so I was told by someone that what it was is that you had a person start out, okay? and that
Okay.
person would put in $500, okay?
Okay.
And then from there, they would have to get 2 more people to put in $500, okay? And then they
Okay.
had to get 2 more to get $500, okay?
This sounds like a lot of money going around.
And so the idea is once you found 8 people to get to this $500, I believe it was 8
Yeah.
people. So then you would get all of that money. So you put in $500, but then you get back $4,000, okay?
Okay.
But the problem is to keep this going, these people need to keep finding more people
Right.
to make this keep going. And so eventually the problem is that you're going to get to a point where there's just no way that people are going to be making back the money that they put in because of how quickly this is going to expand. It sounds great when someone says, "Hey, give me $500," and then you find 2 more people and you'll eventually get $4,000. It's like, okay, but this is going to explode so quickly, right?
Right.
So
It's not
essentially,
very likely that you're going to find this many people to do that, right?
right,
And that's where the scheme comes in, right? Where the first person gets you involved and they already made their money, right? And
right.
then you have to try and do it the same way. It's just a mess.
It is definitely a mess.
Kelsey asked the question, why do we want to make 2 1? I think she's referring to the previous page when we did 2 to the 0 power equals 1.
Right.
Um,
Well,
Kelsey, to answer your question, is because our model down here with our little pyramid, upside down pyramid, we started with 1 person. So our exponent of 0 would essentially be like the first day we start counting this. And then 2 to the first power would be the second day, 2 to the second power, third day, and so on. You start by counting at 0.
right. Because another way,
Okay.
Kelsey, is one person, if we're talking about COVID cases, probably started with COVID, right? It wasn't a group of people that all got it. It was probably one person that started with it first. And so we need to figure out with our model how to start with that first person.
Right.
Okay.
Okay. Another interesting thing with that exponential growth is, right, that model that we did would essentially grow forever and ever and ever. And on our planet, Earth, we have a limit to how far it can grow, right? And that would be infecting every single person on the planet. So there's exponential growth to the cap, right? There's a ceiling that we can't pass. And that's one thing to keep in mind with exponential growth and different models you're going to simulate.
Right.
All right. Okay, what do we want to talk about next? Do we want to get into the mask math?
Sure, let's do some mask math real quick to help people understand a little bit about masks. I don't know if we'll go into calculating the trajectories again, but we could if we wanted to.
Oh, Jaden, why did you want Kai to call us, guys?
1 second. Talk about her math. This
Do
is
we want to talk now, or should I go talk?
okay. So
Okay.
mask math.
Are you good?
Oh wait, Kip, I'm sorry. I'm taking your role. You're supposed to be the
Yeah. No, dude,
drawer.
here, let's each draw a person. You draw yours and I'll draw mine, and then we can have, well, only, I guess only Kelsey can vote on which one's best because no one else is watching right now. But maybe in the comments below when you're watching this afterwards, you can vote who did a better job, Jaden or I.
Yeah. Let's go for.
Okay, are we drawing our people with masks or without masks?
Ooh. Let's start without masks, and then we can add masks on
Without?
later. Yeah.
Okay.
Oh yeah.
Dude, I'm coughing on you. Look at me go.
I should find out time we have the COVIDs. We kind of.
Pulse on my guy.
Kind of ended up in a bad
Dude,
For
my guy
getting
looks.
those eyeballs.
Dude, my guy's pissed.
Okay.
My teammate
So
came with
mask
COVID,
math,
and
right? We have
a couple weeks back.
this
And
misconception with a lot of people that masks don't actually help. That is not true. They certainly do help, and let's just model a situation where we can show why it matters. So, with
so then she tested positive on Friday.
50% effective mask. Okay? So if I put this mask, I'm going to represent it like this, okay? So that's my mask. I just put a mask on my cool green
Dude, you
guy.
got a big mask.
And
Does my mask have to be that big?
yeah, if you want. But at 50% effective, you see how I have 4 little lines here? That means only 2 of these would get out of the mask. Okay? And then let's throw on a 50% effective mask for blue guy.
Dude, my mask is coming in hot.
Okay.
Dude, we got some Dragon Ball
So
Z
then
action going on here.
let's say all of this gets to the blue guy's mask, right? My green has been here, and his is 50% also, right? So that means only one of these gets in, okay? So there's all with combining both of the masks, it is 75% effective, right? With both of them, okay? But most masks are better than 50%, right? If you have a medical one, those are a lot better. If you have a cloth one with a couple layers, those are a lot better than 50%. So now let's say we throw on
By the
instead of
way, we got a
50%.
comment from a Kelsey telling us that our masks or our drawings are pretty horrible, both of them. So we got that coming in.
Oh, well,
Me too. Crossing the fingers.
what do you think about that, Kip?
Jaden will get texted. I think he has a.
Dude, I think mine's way better than yours, but whatever. Look at how pissed off my guy is. Here, let's give him some hair. Some luscious locks.
I don't know if that made it any better, but uh,
Maybe
okay.
maybe yours needs some hands. Here, here's some hands on yours. Okay.
Some hands. Here,
Anyway, so 75% effective. That's pretty good.
yeah, that's just from two 50% effective masks. So now let's talk about 90% effective, okay? So let's change this to 90. Boop, 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 boop. So if two people are wearing 90% effective masks. Boom, 90. And boom, 90. This means we have only 10% gets out. I'm going to just write it as a 10%. Okay?
Okay.
And it's floating over to the blue mask. Okay? When it hits the blue mask, 10% of the 10% gets through. So that is only 1% gets through. Okay? So we start with 90. Boom, only 10 get out. And then it's traveling through there. Boom, hits another 90% effective mask. Only 1% of the original 100% gets through if you have two people wearing 90% effective masks. So that means we have a 99% effectiveness. Okay?
Okay. Well, that sounds pretty good, dude. Maybe we won't get sick then if everyone wears masks with that rate. Only 1% of people
Yeah.
if so, if we do some quick math, that means that if someone that had COVID, if everyone was wearing masks and they were right next to each other and they had 90% effective masks, that means that the person with COVID, if they were in a room with 100 people, only one of those people would walk away with COVID.
Right.
Now, that might be a
That's
little bit of an exaggeration, but I'm just saying that this does show how effective masks can really be. I'm not a health expert by any means, so I'm not going to
yeah.
claim that everyone should just be running around with masks and they're good, but it does show that,
It
that
would help.
it would
Yeah.
help.
And obviously, if someone has their mask only covering their mouth, that defeats the purpose. And if someone's has it loose on their face, that kind of defeats the purpose. But assuming both of the masks fit on the face really good and they're 90% effective, we have this 99% effectiveness.
Cool.
So it's not too bad.
Not too bad. Um, let's keep going then. What else do we want to talk about?
Yeah.
I think we've covered some COVID stuff pretty good. I mean, we did have a question from Kelsey asking how long it would take for COVID to spread to everyone if we didn't have social distancing and such. Um,
If if we use our model
of two
where we're
people,
only doubling, then it would. So we need to get it to about what's the population of the Earth right now? It's about 7 billion.
something like that.
Um, so if we do two, that would be 1 million. Let's see.
So, ready for this? We have the stats actually. We can use an actual formula here if you're curious,
Okay.
which is
We'll use the actual good formula and then we can use ours and show how fast it would be for ours.
okay. So this is just a few states here, and we can choose the highest one, it looks like, which is for every person that has it, there is a 1.11 infection rate. So for every
Okay.
person that has it, they give it to 1.11 other people.
Okay.
So that's almost linear, actually, to some extent.
Yeah, that's real close.
Um,
Um,
let's see what the CDC
so
says, just out of curiosity, if they've got a... yeah, I can't find anything else, but that, by the way, that statistic, so anyone can double check me, I will link in the video, but it's from... Anyways, I'll just put a link to it. and you guys can double check. And this was as of November 14th. So 1.11 is in Indiana and Tennessee. So we got 1.11 to the, should we call it X or T?
We can use T for time.
Okay.
And I'm doing some.
And we're gonna say that this is equal to 7 billion, unless we want to get the exact number. Should we get the exact number of how many people are on the planet today?
Yeah, that works. We need 200. Let's go up.
7.8 billion is what I've got.
7.8 billion. Okay.
Yeah. So
I'm working on a.
let's do 7. So for anyone that doesn't know, I just wrote out in scientific notation 7.8 billion. All that means is that there's, you go and add 9 zeros to the end of that.
Right. So it would be between two. Are we assuming T is days? Is that what we're calling?
I'm wondering if we should make it like, because the person, I guess, a person's infected within 14 days, or for 14 days kind of deal. So if they're infected for 14 days, maybe we should make T equal to 14 days, since they're only giving it to 1.1 people within those 14 days.
Okay.
But maybe not. Maybe that's inaccurate. What do you think?
No, I think that sounds good. Then we have T equals, it's between 218 and 219.
So 219 times 14 then?
Yeah.
And that
And then
equals, what does that equal?
If we say it's 14 days, that's 3,066. And we can divide that by year to get. It would take about 8.4 years at that rate.
So I guess this doesn't entirely answer Kelsey's question, because this is the current statistics, right? Which means that this is with the social distancing and with masks mandates, that we're getting this 8.4 years. So it could be a lot quicker if we didn't have everything in place. And just really quick to show the algebra that Jaden did to get to this number, what you do is you take the log of both sides of this equation. So you take the log of 1.11 of 1.11t, like this, and set this equal to log of 1.11 of 7.8 times 10 to the 9th, right? That's what you did, I'm assuming?
Yep.
And so these logs, or this is to the t, sorry. And so what a log does is it's like the inverse of an exponent, the same way division is the inverse of multiplication, right, Jaden? Is that a pretty good way to explain what it is?
Yeah, that's perfect.
Or the way that subtraction is to multiplication.
Yes.
So I know a lot of people get scared when it comes to logs, and logarithms math, but it's really that simple. You just look at it the same way that you would, you know, if you want to figure out what t is, well, you need to take the inverse of the exponent, and that's the log of that.
Yep, it's just another operation that
Yeah.
it's just a little less common.
Because I remember in high school, you know, they taught you some formula where it's like log of, I don't know, b of a or something equals c, and that always just confused me to memorize that. And
Yeah.
so if you just think of it the same way you would as, you know, I guess taking the opposite, it always helps me out a lot more than trying to memorize some formula. So.
Yeah, for sure.
Well, Jaden, it's 8 o'clock. Do we want to keep going, or are we good?
I guess we could just do a quick using our if
Oh,
it doubled every day.
okay.
Show
Yeah,
how fast
let's
that
go
would be.
for it. So now we're saying that we've got 2 to the t equals
Yeah, that would be
7.8 times 10 to the 9th. And now this would be, you know, maybe this would be how quickly it would spread if we weren't wearing masks, right? That every person that got infected 2 people. I mean, that's, when you think about it, that's really not infecting that many people still, right? If I got COVID and I only infected 2 other people, that's really not that many people for me to be infecting with COVID. But we'll see how fast this goes.
Yeah, in our situation, it would be t equal, it's between 32 and 33.
30,
So,
is that days? Are we going to multiply this by 14 now?
we can do that by the 14, kind of like we did.
So 33 times 14.
462.
462. And then when we, you know, that's going to be a little over a year, right? Like a year and 100 days. Close to it.
Yep.
So that's why wearing masks and social distancing is important, because in this case it would take only 1 year, you know, a year and a third.
A year and 3 months about.
Yeah.
Yeah, that's pretty
For
crazy.
everyone to get it. And we know that that's not the case because we're almost coming up on a year since this started, and not everyone on the planet has got it yet. So.
Yep.
So that's good that we're below 2.
That is. Good thing it's not doubling.
Good thing. Well, the hospitals would be really overwhelmed. So, anyways, that's some quick, you know, math on exponentials and why it's important to do what doctors tell you to do.
Yeah. Wear your mask, kids. All right.
All right.
Thanks for tuning in, Kelsey. You're pretty much our best
listener.
Best listener. That's right. If she's still on, watch her just not be on anymore.
I don't know. She hasn't commented in a long time, so.
I know. We did this for you. Okay. Well, I feel like that was pretty good.
Yeah, it was pretty good. We're getting better and better. Hold on. Let me